The production department of a company requires 3600 of the raw material for manufacturing a particular item per year. It has been estimated that the cost of placing an order is rupees 36 and the cost of carrying the inventory is 25% of the investment in the inventory. The price is rupees 10 per kg. The purchase manager wishes to determine an ordering policy for the raw material. Recommend the manager in following aspects: the optical lot size and the optical reorder time. So we are provided with the information 3600 kg of raw material, which is the demand, and the cost of placing an order is rupees 36, so which is the ordering cost or setup cost, and the cost of carrying the inventory 25% of investment in the inventory, which is the holding cost or storing cost, and the price is rupees 10 per kg, which is cost per unit, and we have to find the optical lot size EOQ and the optical reorder time. If optimal reorder time is asked, we need to find the cycle time. Before solving the problem, we need to have a general knowledge about these formulas. EOQ is given by root over 2 ds by s, where d is the annual demand, s is the setup cost or ordering cost, and s is the holding cost or storage cost. And cycle time is equal to number of working days in a year divided by n, where n is given by annual demand divided by EOQ, and the optimal number of order is given by n d divided by EOQ, and the total variable cost TBC for constant demand is given by carrying cost plus ordering cost, which is EOQ h divided by 2 plus ds by EOQ, which eventually gives root over 2 DHS, and the total annual inventory cost TC optimal is given by DC plus ordering cost plus holding cost. As we know that ordering cost and plus holding cost gives you root over 2 DHS, so we can substitute the answer here. And the reorder point or reorder label ROP or ROL is given by D dash into L plus safety stock, where D dash is given by demand, which is annual demand, divided by number of working days in a year. As in the question, the demand is 3600 kg, ordering cost is rupees 36, and the holding cost is 25% of the investment in the inventory. Cost per unit is given at 10 per kg, and we need to find EOQ and optimal reorder time. And the optimal reorder time is given by cycle time. But if we are asked to find only the reorder time, we use the formula D dash into L plus safety stock, where D dash is given by annual demand divided number of working days in a year into lead time plus safety stock. So firstly we find EOQ, and the formula of EOQ is given by root over 2 ds, and from the question D is given by 3600, S is given by rupees 36, H is 25% of the investment in the inventory. Now we can write it as 2 into 3600 into 36 divided by S is given as 25% of the investment in the inventory. So that means we can write 25% into cost per unit, which is 10. As mentioned above, cost per unit is given as 10, so we can write 25% of 10. So by calculating we get 322 units. Now as mentioned before, the optimal reorder time is equal to cycle time. So cycle time is given by number of working days in a year divided by n, where n is given by d divided by EOQ, and the number of working days in a year is noted by n. So we can write this as this. Now substituting the value, where n is given 300, d is given 3600, and EOQ is found to be 322 units. After calculating, we get this as 26.83 days, which is equivalent to 27 days. Now if a graph is plotted, we obtain EOQ as 322 units here, which is the maximum inventory level. And ROL means reorder level or reorder point, which is noted here. And L means lead time. The y-axis is inventory level and the x-axis is the time.